Okay, so first I'll give you a brief introduction about what will happen in the interview.
Can you give an idea around what scale we are looking at?
Okay. So who will be populating this caching layer?
Hey guys, what's up? So we at Codebuddy are bringing you a system design interview live. Okay, so this is exactly how it happens in a real setting, and feel free to pause through the video so that you understand better. And please do leave your comments, doubts, questions, suggestions in the comment section below. And this video will be followed up with an analysis video where we will be analyzing the answers that were given and what could have been a better answer really. And I don't need to tell them, right? They know that they have to like, share, and subscribe. You know, right, that you have to like, share, and subscribe, or else you will miss the analysis video.
This is Shivam here. Welcome to the system design interview. How are you doing?
Yeah, Hisham, I'm great. How are you?
Yeah, I'm great as well. So let me first start by introducing myself. Um, my name is Shivam, as you know. Use cases as well, right? Uh, so you tell me, please, can you introduce yourself?
Yeah, sure. So I just completed 3 years in the industry. So initially I joined as an Android developer.
Okay, that's great. So are you ready for the interview? Can we start?
Yeah, sure.
Okay, so first I'll give you a brief introduction about what will happen in the interview, right? And then we'll move over to the question. So basically, this interview will be around 55 to 60 minutes, approximately. Uh, and I'll give you the problem statement. The problem statement would be a high-level one. So don't worry if you don't have the answer, and I'm not even expecting that. What I am looking for is your approaches, right? Whether you are able to identify the pros and cons between different approaches, right? And it will be more of a discussion.
Got it.
At the end of the interview, you will have 5 to 10 minutes to ask any questions that you have about the company or any other questions that you have. Throughout
Got
the
it.
interview, you feel free to ask me questions if you have any doubts about the question or the direction that we are heading in. Okay. So Prashant, what I'll do now is I'll list down the problem statement. So in our system, users can create their account or profiles. Users can follow other users, and users can, right? So what is the timeline? So basically, a timeline means that the users can see the posts which have been created by the people that they follow. Okay. Do you have any questions around any of these?
I think the problem statement looks clear. So should I list down the APIs first that follows these requirements?
Sure, whatever works for you.
So I think the first API as per the first requirement is creating a profile of the user. So that would be a post API to create user profile.
Okay.
Then I think there would be a API to get user profile.
Okay.
And the other thing is a user can follow other user, right? So I think there would be API to for a user to follow another user. There would also be a post API, follow user, and let us say it takes a user ID. So this user ID would be of the user that this user is following. Then I can create a post. So there would be a post API to create post. This will have data around whatever data we have in post, right? Maybe image URL and the other data around this. Other API would be I can comment on the post, right? So it would be a post API to comment. This will basically take post ID, denoting that I'm commenting on this post, and this will also contain some data around comment. So I have one question here. So can comment only contain normal text, or can comment also contain like images and all?
For the sake of simplicity, let's consider that a comment is only a text.
Let us say we have a comment here, which is a string. The next API would be a get API to get the timeline. This API basically returns all the data that a user sees on their timeline, right?
Okay.
And maybe we'll want to make this API paginated as well because there could be too many posts in a person's timeline, right? So next, I think I can talk about the entities that we'll have here. So
Yeah.
talking about the first API that we have to create a user profile, this indicates that we'll have an entity called user.
Okay.
So so I'll create the user entity over here. So user entity basically will have a ID, which is the user ID over here.
Okay.
And it will have certain other attributes like name of the user and email ID of the user, right? And maybe we'll have email ID as a unique key over here because email ID can't be same.
Okay.
The next API that we had was follow user API.
Okay.
So for that, what we can do is we can create a follow table. This will also have a unique ID,
Okay.
and then this will have a user ID and a follower ID. Basically, this denotes that this user is being followed by the other user. The user ID and follower ID that we have, they corresponds to the ID, which is the primary key for user table.
Okay.
Next API that we had was to create a post. So to create a post, we'll have one more table.
Okay.
So post will also have ID, which denotes the unique ID for post. Now post will have certain metadata, but for example, who was the user which created this, when was the post created. The other thing would be the image link. So this image link would basically contains the link for the image that we can actually store at a file system, DB, or some sort of blob storage, right?
Okay.
And over here, the user ID that we have is again uh, a foreign key for the primary key in the user table. Next table that we'll have will be a comment table. Comment table will also have an ID. Now, this indicates that this comment was made on certain post. So it will have a post ID. It will have a user ID denoting that this comment was created by this user, and it will have some comment text. So here, the post ID that we have corresponds to the ID for post table,
Okay.
and the user ID that we have, it corresponds to the ID for the user table.
Okay.
So yeah, I think this covers it. Timeline is basically an aggregation on top of this. So to get a timeline, we basically get all the followers for a user, and for all those followers, we can have a join and then get all the posts for all of those followers.
Okay. So Prashant, I had a question
Right.
here.
Yeah.
Uh, how do you get the primary? How do you derive the primary key in the user entity?
So in this case, I think the primary key can be a very simple auto increment ID.
Okay.
Uh, it could be a UUID as well, but I think auto increment ID would be simpler to create. And we can, if we are using a asset data store like MySQL, we can be guaranteed that the ID is always unique and always generated auto incrementally. So
Okay.
I think
Right.
now I'll move on to how the architecture will look like from top to bottom. So
Okay.
first thing that I can think of is that we'll have some sort of uh, gateway layer,
Okay.
which so this gateway layer is basically mm, the outside world layer for our app. Also, this could act like a load balancer as well.
Okay.
Uh, so now what this gateway layer or load balancer will do is it will talk to different services that we have. So now talking about the first API that we had to create a user profile. So for that, we'll have a user service. What will happen is the API call will come to gateway. The gateway will call user service, and the user service will call the underlying data structure. Is a simple MySQL database.
Okay.
So user service will talk to this MySQL database.
Okay.
So to create a user profile, it will store the data into MySQL, and to get a user profile, it will get the data from MySQL DB.
Okay.
The next API was to follow a user. So let us say we have a follow service for that.
Mm-hmm.
So this will also store the data into the MySQL
Okay.
DB. The next service that I can think of would be the post service. So post service will get a post API call to create post. So for the create post API, we'll get a call at post service, and then the post service will basically create a post entity into the data store.
Okay.
Right. The next API call would be, that we had was to create a comment. So what we'll have is we'll have a comment service. For this, also we'll have the same flow only that will call the MySQL DB to store the comment.
Okay.
Right. And the final API call that we had was to get the timeline.
Okay.
So for that, we'll have a timeline service. When we get a API call to get timeline for a user, right? Um, this service will call, first of all, this service will call follow service uh, to get all the followers for a user.
Okay.
And once I know who our follower are there, then I can basically simply call the post service to get all the posts for all of those followers.
Okay. So this is the get timeline API call that you're talking about, right?
Yes.
Okay. In the create post, you mentioned that there is an image URL. Where would that URL come from?
Yeah. So there would be some sort of blob storage, for example, maybe S3 or some other sort of file storage.
Okay.
So basically what we'll have is we have some sort of blob storage.
Okay.
Blob storage, basically post service will talk to this blob storage, right? And basically it will store the images over there. And the link to those images would be stored in the actual post data that we have.
Okay. So can you walk me through the flow when what happens when a user creates a post?
Okay. So when a user creates a post, so we get a post API on our load balancer.
Okay.
So the load balancer calls the post service to create the post. Right. So post service does two things. First of all, it creates or stores the image on the blob storage,
Okay.
and it gets the links for the link for that image.
Okay.
And after that, it basically store that link in the post entity that we created, and that is being stored into the MySQL DB afterwards.
Okay. Can you talk about the order of these calls? Is the objects saved first in the blob storage, or is the entity created first?
So I think first we'll need to store the object onto the blob storage.
Okay.
Then only we can create the entity into the DB, because if the image is not actually stored and we create the entity, then user might end up seeing a post for which image does not exist. I see one problem here, which is that to get the timeline, we need to call our followers and then call the post service to get all the posts.
Okay.
So can you give an idea around what scale we are looking at?
Exactly, sure. I'll do that. Uh, we are actually aiming at a system where the monthly active users are close to 1 billion. Let's say the system is more read heavy than being write heavy, right? So reads are far greater than the number of writes, and let's say the writes are in the order of 100 million per day. Does this give you an idea?
Yeah, got it. So, uh,
So do you think your design would be able to handle this kind of load?
so yeah, I don't think this design would really scale over here.
Okay,
So basically, I see two major problems over here.
okay,
First is our read flows and write flows are basically the same flows only.
okay,
So every time a read would happen, we'll need to take some or the other lock, right? So that would end up increasing our read latencies. The other
okay,
problem that I see is with the timeline service that um, if I have a lot of followers, then basically I need to do some sort of join to get all the posts for all the people that I follow, which is actually a slow query.
okay,
And the other problem that I see is everyone is reading from the same MySQL DB and writing to the same RDS. So that would become bottleneck at one point or the other.
okay. So Prashant, let's handle each of these problems one at a time.
So the first problem was that our read flows and write flows were not separate, right? So
Okay,
one thing that I can think of is we basically create two layers, two separate layers for handling read and write separately. So what I was thinking is instead of having flow like this, uh, what I'll do is I'll create a read and write API layer,
okay,
right? Uh, so let us say I have a read layer. So all the read APIs which gateway gets, it forwards all of those to the read layer.
okay,
And similarly, we have a write API,
okay,
right? So all of the calls where writes are happening, those calls would be forwarded to this layer. So now let's talk about the first read flow that we'll have. That would be to read the user service, right?
okay,
The profile of a user. So for that, the read API will call user service, and user service will call the RDS.
okay,
Um, Now, the other problem that we were already seeing was that our RDS will become bottleneck at one point or the other, right?
okay,
So to tackle that, I think what we can do is we can have some sort of read replicas.
okay,
Basically, any read flows that are happening, they can always happen from the read replica instead of always reading from the master, so that master is always available for writes. And we can also scale our reads by scaling the replicas. Okay, so I'll talk about the follow service first. So now follow service would lie into the write API flow.
okay,
So basically we'll get a API call on the write API write layer,
mhm,
and then the write layer will call the follow service
okay,
to create a write, and then it will cause a create a write on the master.
okay,
The next write flow was to create a post. So for that also we'll get a API call on our write API, and that will call the post service. The other flow was the comment service. So for comment also, I think the write API will simply call the comment service, and the comment service will then write to the master.
okay,
Uh, the other major read flow is the timeline flow.
okay. Before that,
So
you before that, can you also draw a link between, like you mentioned, right? The reads would be served from the read replicas. Can you also join the user service with one of the read replicas? so that we have.
Yeah, makes sense. So now talking about the other major read flow, which was getting the data from timeline. Uh, so the read layer will call the timeline service. Timeline service basically calls follow service to get the data and post service over here. Uh, but I still think that would be slower.
So basically, what you're
So
saying is that the get timeline call will be slower because it's first calling the follow service and then it's calling the post service, right? Why do you think
yeah,
that it
right.
would be slower?
So let us say I have, let us say 10,000 followers or a million followers, right? So to get all of the data from follow service and then using all of those user IDs to get all of the posts would actually be a slower query. And since we know that our reads are actually very higher, I don't think this can really scale.
Okay, but you already mentioned, right? We will be paginating the data.
Yeah, that I understand, that we can do. But let us say you have a million users.
Okay.
Uh, you can paginate the post, but you need to know that, okay, this was the user who created the recent post.
Okay.
So that join would always be there.
Okay.
So that is what I think would be the bottleneck over here.
How do you resolve that bottleneck?
One of the solutions that is coming to mind is we use some sort of asynchronous approach that guarantees that everyone will get my post after a certain time, not immediately.
Okay.
Uh, so for that, what I'm thinking is the create post flow would look something like this. That gateway will get a call. The call will go to read API. The read API will call post service. Now post service will was writing to the DB, right? Along with that, it will also do one thing, which is it will call the follow service
Okay.
uh, that send this post to all of my followers.
Okay.
Okay. And what then follow service can do is it can push an event to a queue for all of my followers.
Okay.
So let us say we have some queue, right? Now, what follow service will do is a post service will call follow service that, okay, send this post to all of my followers.
Okay.
Then follow service will basically push post for each of my followers to the queue.
Okay.
And then we can basically create a timeline for each of my followers by reading data from this queue.
Okay. So let's say a user has a million followers. So you are expecting the post service to fetch all the followers, which is a million records, right? And then create events for each one of them.
So no, not that. So basically, post service will simply call follow service that this is a post ID,
Okay.
and then what follow service can do is it can keep on iterating over the followers that I have,
Okay.
maybe paginated iteration,
Okay.
and then slowly it can keep on pushing that post ID for that follower.
So what you are saying is that so let's say uh, a person with 1 million followers uh, creates a post in that synchronous call. Uh, the post service will route that event to the follow service, and the follow service will, during that synchronous call, will continue to iterate over the million followers and create events for each one of them, right?
Yeah, I think if we do this in like a synchronous flow, it would be a problem.
Okay.
So maybe what we can do is post service, when it's asked to create a post,
Okay.
it writes the post at least for me immediately
Okay.
and returns to me that, okay, post has been created.
Okay.
And then asynchronously, we can keep on creating a timeline for all of my followers.
Okay. But
So that,
so what you are saying is that the post service would write it to MySQL, and then the post service, after returning the response, will asynchronously keep on creating a million events. Is that what you're saying?
Yeah, like I'm not exactly sure where the event should lie, whether the post service should be creating all of these events
Okay.
or post service simply calls the follow service. But actually, it is not the responsibility of follow service anyway. So yeah, I'm thinking that post service gets maybe let us say thousand followers in batch, and then create events for all of them.
But you
But yeah,
understand,
I understand
right?
this might end up creating too much data.
It can also hog the memory, right? Because uh, we are still receiving a quantum of 100 million writes per day, right? And that will basically hog all the instances where the post service is running. So can you think of a way? So let's take one case, right? So let's say a celebrity basically creates a post. That celebrity has 1 million followers, and our post service asynchronously creates events for each one of them. Now, who is reading from the queue? The queue that you mentioned. Who is reading those events from the queue?
Um, so here I've drawn the link directly between Q and MySQL, indicating that we need to write this data to the MySQL. But
Okay.
ideally, the timeline service should be reading from this queue
Okay.
and creating timeline for that user.
Okay. So now the burden is so first of all, just to be clear, we are still storing the timeline in the MySQL, right? And
Yeah,
the burden is on the timeline service to read from the queue and write it into MySQL, right?
yeah,
But if we revisit the constraints of our system, right? I mentioned that the system is read heavy rather than write heavy, right? So the timeline service already has a lot of load. Do you think that it will be able to handle uh, even the write load also, because each write is also creating events? So it will have to handle
yeah,
not only the reads but also the writes.
yeah, makes sense. Um,
So can you think of another way where we don't involve the existing post service or the timeline service, and we can still read from the queue and write to MySQL?
mm, like I'm not really sure. Can you point me in some direction over here?
So basically, like I mentioned, right, can we introduce a component which can read from the queue and then write into MySQL? Can you think of can you introduce such component which can do this job, and we don't have to involve the post service or the timeline service?
Okay. Yeah, I think what we can do is instead of having all of this, we have certain consumers of the queue.
Okay.
Okay. So let us say we have multiple consumers over here.
Okay.
So what consumers will do is they'll read message from the queue.
Okay.
And so now we can also do one thing that the post service need not push all the 1 million events to the queue. It only pushes one event, which is that this user created this post to the queue. And then this queue is being read by multiple consumers. And what those consumers would do is they'll read the post from the queue, and in batches, they'll call the follow service to get all the followers for that user.
Okay.
And after getting that, they'll basically call the RDS to create timeline for those users. So in this way, I think we'll be able to make sure that our timeline service and post service are not really impacted by this rights.
Okay. So what you're saying is uh, that the post service would first write into MySQL, right? and then it will push an event. It will push a single event, right? And then we have consumers which will be reading from the queue. They will call for the followers of that particular user, and then they will write into MySQL, right?
Yes, right.
Okay. Okay. Even now, do you see any bottleneck here? First of all, I want to understand how does the replication between your MySQL master and read replicas happen?
So, in case of MySQL, this could be a normal bin log replication,
Okay.
which is after you write to the master,
Okay.
the master like asynchronously replicates all of the data across all the replicas. So it won't be a synchronous and immediate replication. There would be certain lag, which I think is okay with our use case, that even if I see my timeline with some delay.
But do you still think that our problem has been solved? The problem that you mentioned where uh, the get timeline would be slower because first we are trying to fetch all the followers of a particular user, and then we are trying to fetch all the posts by them.
So I don't think these two calls are anyway there. The timeline service would directly be calling the replicas to get the data.
Okay.
But the other problem that I see is since our reads are too much, so even after we shard the data and have read replicas, we might still run into some issues because of our read throughput.
So right now, what I understand is that the writes for each of the in each of the case, what we do is we fan out the writes. We write it into the MySQL master, and then we write it into a queue, and then we fan it out into multiple events, which is then replicated into the read replicas. And you are saying that uh, for getting a timeline of a particular user, we will be querying the read replicas and get the timeline. Is it? So you're pre-computing.
Yes.
Okay.
Yes, correct.
Okay. But do you still think that we will be able to serve a read load for 1 billion users through RDS?
Yeah, I think since RDS is not really optimized for very high RPS, it can do joins very quickly and all of that. So the other thing that we can do is have some sort of caching layer on top of RDS.
Okay.
That when we are writing to MySQL master, which gets populated to read replica, uh, after that, the timeline call which is happening, it is reading from the read replica, but there is a cache, either write through or read through cache on top of this. So when a call comes to timeline service, it checks whether whether we have the data in cache. If not, it gets data from RDS and populates the cache. And the next API call could directly simply be served from the cache only. Now, this caching layer could be a simple Redis
Can you
cache.
draw that cache?
Yeah, sure. So similar to the read replicas that we have over here, we'll have a caching layer.
Okay.
So now what happens is instead of timeline service directly talking to read replica, it talks to basically two things. First is the caching layer and the database layer. So it calls the caching layer. If data is not present in the caching layer, then it calls the data store and then basically updates the cache. So this way we can make sure that our um, impact on um, data store is less.
Okay. Okay. So what you're saying is that we'll have to cache the pre-computed timelines of all the users, right? Do you think it's beneficial to pre-compute the timelines for all the users? Or we are talking about 1 billion?
So I'm not really caching for all the users. So this is a
Okay.
lazy cache.
Okay.
So first time I get my timeline,
Okay.
the cache won't be there. So a call will go to the data store and my cache will be populated at that point of time, maybe with some sort of expiry TTL, maybe let us say 1 day, assuming that a user comes more than once per day. So
Okay.
we won't really be creating cache for everyone. We would be creating a lazy cache. But if something like this that happen that everyone is coming to the platform at once, then maybe we can have some sort of eviction on caching based on number of items that we have on the caching layer
Okay.
to make sure we are not really caching all of the data.
Do you see any other bottleneck in your design?
You're talking about the read flows.
Uh, let's go back to the APIs, right? And let's see if we have let's see each one of them one by one. Let's go back to the read APIs because like I mentioned, the system is more read heavy. So let's just focus on the read APIs now. So the first read API is the get user profile. So let's talk about this one. Can you go back?
Yeah, yeah. I think I missed that. Uh, so as of now, our get user profile API is always we are always reading from the replica only.
Okay.
Uh, so um, I don't think we can cache all of the data over here because some of the data like the post that a user created
Mm-hmm.
needs to be strongly read write consistent right. If I create a post, I should be able to immediately see that post. So I don't think we can cache all of the data over here, but maybe we can introduce a caching layer that caches some of the data like basic information about me and maybe total number of followers that I have, total number of posts that I have created. So some of that data we will be able to cache. Uh, but some of the data like posts and all, we can directly query from the read replica.
Okay. So what you're saying is that since you want a strong read consistency uh, in the post of the user, right? So you would not be caching the post directly. You would be caching the other metadata of the user, right? Can you draw another cache uh, for
Yeah,
that?
sure. So this caching layer is basically for the user service.
Okay.
So similarly to what we were doing for the profile service, the user service will call read replica, and this is also some sort of lazy cache only. We don't really need to create the cache for the users who are not active. So when user opens the app for the first time, at that point of time, we can create the cache. And for this, I think the TTL could be a bit higher because things like followers of the users and the other metadata around user does not really change that frequently. So we can have a higher expiry time over here.
Okay. So let's look at the other get APIs that you have.
So I think apart from this get API, the other get API was to get the timeline.
Okay. So, so
And
let's
yeah,
get back to the get timeline API, right? Because that is probably the selling point of our system. I think what we have achieved is that first we will be reading from the cache, right? Cache, you are saying that the cache will store the pre-computed timelines for every user, right? With the TTL. And then if the timeline is not found in the caching layer, our service would be reading from the uh, read replicas, right? So who will be populating this caching layer? I think you mentioned it would be the consumers. Can you please draw a link between the consumers and the caching layer? Okay, that's great. Uh, yeah, thanks, Prashant. These are all the questions that I had. Now it's over to you. We still have around 5 minutes left. Do you have any questions for me? CICD. Does that answer your question?
yeah, it does.
Okay. Thanks, Prashant. It was nice talking to you. And probably the HR will get back to you on this.
Yeah, thanks a lot, Shivam. Have a nice day.
See
Bye.
you.